Assalamualaikum and hello everyone. My name is Nurul Akila binti Muhammad Nasir and I will be the first presenter today. So the topic for our presentation is a project-based learning PBL from our subject PTT 458 Quality Control Assurance. So the title for our presentation today is a control chart variable for Haw Flakes. So for the introduction part, the item chosen for this project is Haw Flakes. It's one of the most famous children's snack food that's sour and also tastes a bit like a membrillo. Haw Flakes are made from hawthorn fruit with a disc pattern of 2 mm thick, small and in a pink color. They typically come in a type of snacks like small rolls as well as brittle. When they peel off each one of the discs from the stack one after one another. So the reason it is important to construct up a control chart for a product is that it can offer a better higher productivity, reduce overall deficiency and output deformity, and also improve profit yet at the same time lower the cost. So control charts are commonly used to analyze the variation of the characteristic between both the nominal and the exact context. So the distinction among normal and abnormal variant are identified and the characteristics are kept in check by having taken all the appropriate action. So the objective of the quality control is a prevention. Control chart for variable are used for this project because they allow more effective control and offer additional data on the process performance. So these charts are recommended because they have been presented with an estimate of the central tendency as well as the distribution of the case. So this project use the measurement which are the control chart X, mean control chart X bar, range control chart R, and standard deviation control chart S. The first step to construct the control chart is by identifying the problem of the Haw Flakes snack. As you can see from the left side is the Haw Flakes snack that stuck together, and on the right side is the normal Haw Flakes and the broken flakes after the packaging was opened. So the problem is that the Haw Flakes is in a brittle condition. Next step is the quality characteristic to be measured or selected. So for this product, the quality characteristic that we measured is the diameter of the Haw Flakes. So the diameter was measured by using the ruler.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraniza binti Aziz. I will continue the presentation. So the third step is the data collection. The sample that we choose is about 25 sample. With each sample have 5 subgroup. In here, as we can see, the sample that chosen is 25, and the subgroup for each sample is 5 sample. Next, after the data of snack diameter is collected, we continue to the trial center line. The fourth step, which is the trial center line, was determined. In here, the X bar, which is the mean for the each sample is collected, where the subgroup for all the 5 sample size will be plus and divided by 5, as our subgroup sample size is 5, to get the average for the each sample, and then after the X bar being calculated, we calculate the R, which is range. For the each sample, we need to calculate the range, where the range is calculated from the largest number for in the subgroup minus with the lowest number in the group. Next, after the X bar being calculated for each sample, the X bar total X bar being calculated from the first sample until 25 samples. So the total X bar total X bars can be used to calculate the XD bar, which the mean for the all total 25 sample we divided with 25, so we get 2.84624 centimeter for the XD bar. And for the calculation for R bar is also same. After the R bar for each the R for each sample being calculated, so the total of all 25 sample being total up, and then it used to calculate R bar, which the total up of the R bar for 25 sample is about 3.11 centimeter. We divide it by 25 sample, we get 0.1244. After that, the fifth step is the trial control limit were determined. In here is a X bar chart. So from the previous calculation for the XD bar and the R bar, we can calculate for the upper control limit for the X bar and the lower control limit for the X bar. For the upper control limit X bar, the formula as we can see here, the X bar from the previous, which is 2.84624, will plus with the A2. A2 is our constant, which is for the subgroup n equal to 5 is equal to 0.115, and times with the R bar that calculated before, which is 0.1244 centimeter, which after the calculation we get the upper control limit X bar is 2.918019 centimeter. After we get the upper control limit X bar, we goes to the lower control limit X bar, which the difference is only at the sign, where previous we on the upper control limit we plus, but for the lower control limit we minus. So the XD bar will minus with the A2, which is constant, times with R bar, which we get the lower control limit for the S bar is 2.774461 centimeter. After all the upper and lower control limits for the S bar get, we can use to create the S bar chart. So as we can see here, there are some points that over the lower control limit that can be used to revise next. Next is the sixth step is also same as the previous, but in here we goes to trial control limit for the R bar chart. In here, as same as the S bar chart, there are upper control limit and lower control limit for the R bar need to be calculated. So for the calculation for the upper control limit R bar, the formula is D4. D4 is a constant, as our subgroup sample is n equal to 4, so the constant is about 2.282 with times with our R bar previously, which is 0.1244, so we get the upper control limit R bar is 0.262982 centimeter. After we get the upper control limit R bar, we goes to the lower control limit R bar. In here, the constant that we use is D3. The constant is equal to 0, so R bar is 0.1244 centimeter. So the lower control limit that we get is 0. After we get upper control limit and lower control limit for the R bar, we can create the graph, R bar graph. So as we can see here, there are some points that more than the upper control limit. So the both point that over the R bar chart and X bar chart needs to revise. The point need to be revised in next step, which is the revised data for the control in the control chart report.
Assalamualaikum to Dr. Fiza and Dr. Rusniza. My name is Nur Ashiki Mitizanuddin, and I will continue on the revised control chart. The revised control chart is done to take the corrective action on the original control chart. In this revised control chart, The out of control point were used in the calculation of the control limit. There are two types reverse control limit, which is reverse X bar chart and reverse R bar chart. For the reverse X bar chart, the corrective action is taken on the lower control limit, while for the reverse R bar chart, the corrective action is taken at the upper control limit. This is the trial control limit for the X bar chart. As we can see from the chart, there are 3 points that up from the lower control limit, which at the subgroup 14, 20 and 23. Thus, these 3 points is need to eliminate to get the new control limit. To get the new control limit for the revised X bar chart, this lower control limit formula is used. Based on the appendix 2 for the subgroup of 5, this data is obtained. Thus, based on this data, we insert into the formula and get the new lower control limit value, which is 2.77447. To get the new control limit for the revised X bar chart, this lower control limit formula is used. Based on the appendix 2 for the subgroup of 5, this data is obtained. Thus, based on this data, we insert into the formula and get the new lower control limit value, which is 2.77447. After that, based on the lower control limit value, we plot the revised X bar chart. As we can see from the new control limit chart, all the points are between the upper and lower control limit. Assalamualaikum to Dr. Rosniza and my fellow friends. My name is Nur Fariza binti Ahmad Shah, and I will continue presenting about the R chart. As we know, R chart is plot the average range and the limit of the range. It is used to detect changes in variation within the subgroup. From the graph of the trial control limit of R chart, we can see that there are 3 out of control points, which is at point number 14, point number 20 and point number 21. It shows that there must be something wrong at that part. So, we need to remove that out of control point. To remove the out of control point, we need to revise the R bar chart. So, based on the appendix 2 for the subgroup number 5, we can get all the constant factor, which is this. All this is the constant factor that can be get from the appendix 2. So, we will be substitute into the formula, and the UCL R bar will be get 0.263024. This is the revised control limit of R chart, which is the R chart is between the upper control limit and the lower control limit. It's between the range. That's all from me. Thank you.
Assalamualaikum and hi, I'm Kasrina. So today I will present for normal distribution part. So what is the use of normal distribution? Normal distribution curve was used to estimate the proportion of the process that we perform within specification limit, which is LSL and USL. And the analysis on the process data is important because it will avoid targeting wrong or lower important needs of the customer. Okay, next I will present the result of normal distribution for X bar chart, R chart, revised X bar chart and revised R chart. Trial control limit X bar chart. So in this slide, subgroup sample size is equal to 5, standard deviation is equal to 0.05348, which obtained from the appendix. Next, mean value stated has been obtained from the previous calculation, which is equal to 2.84624. Based on that, USL and LSL can be calculated and used in the normal distribution for the X bar chart. Trial control limit R chart. In this slide, subgroup sample size is equal to 5, standard deviation is equal to 0.05348, which obtained from the appendix. Next, mean value stated has been obtained from the previous calculation, which is equal to 0.13149. Based on that, USL upper sigma limit and LSL lower sigma limit can be calculated and used in the normal distribution for the R chart. Revised control limit X bar chart. In this slide, subgroup sample size is equal to 5. Standard deviation is equal to 0.05348, which obtained from the appendix. Next, mean value stated has been obtained from the previous calculation, which is equal to 2.84624. Based on that, USL and LSL can be calculated and used in the normal distribution for the revised X bar chart. Lastly, revised control limit R chart. In this slide, subgroup sample size is equal to 5. Standard deviation is equal to 0.05348, which obtained from the appendix. Next, mean value stated has been obtained from the previous calculation, which is equal to 0.13149. Based on that, USL and LSL can be calculated and used in the normal distribution for the revised R chart. So to conclude, all figures show the process exceed the USL and below LSL, which are non-conformant. Due to that, this process is accurate, however not precise. Okay, that's all from me. Thank you.